Okay, everybody. The time is about 12:02, so we'll get started. Good afternoon and welcome to today's How Tuesday webinar covering the portal's coastal and ocean acidification data. My name is Carl Villacova and I am the Communications Director for Monmouth University's Urban Coast Institute, which is located in West Long Branch, New Jersey, about a mile from the beach. And I also serve as the manager of the Mid-Atlantic Ocean Data Portal. Our collection of 7 acidification-related maps in our water quality theme were recently expanded to include 20,000 additional sites where sampling is currently being or has been conducted recently in the region. Taken together, the maps are a valuable tool for the Mid-Atlantic Coastal Acidification Network, or MACAN, in its work to develop a network that monitors for changes to the region's water chemistry. In just a little while, Carly LaRoche, a Ph.D. candidate at the University of Virginia's Department of Environmental Sciences, will take us behind all of the dots on the maps and tell us about where the data came from, what it can teach us, and what's coming next in terms of acidification data on the portal. Carly's current research focuses on coastal carbonate chemistry trends at the Virginia Coast Reserve Long-Term Ecological Research Site, and she also studies the influence of wastewater effluent on coastal acidification in Buzzards Bay off the Massachusetts coast. Over the past year, Carly has been collaborating with MACAN and MARCO to produce a coastal and acidification monitoring inventory for the Mid-Atlantic region. It's just a few organizational items before we kick things off. This webinar is being recorded for the benefit of those who can't attend. At the end of the presentations, we will have a Q&A session where you can ask Carly about anything you've heard or myself about any questions you might have about the portal. At that time, you can raise your hand and unmute yourself when I call on you. And you're also welcome to type questions into the chat at any time during this webinar. So I'm sure many of you on this meeting are very familiar with the portal, but a little background for those who may not be. What's on the portal? Currently, about 6,000 map layers organized under just over a dozen themes, which all can be activated one at a time or in combination with each other. And these data show long-term trends on ocean areas. We have a lot of tools for users to share maps and collaborate together on projects and groups. And we have lots of instructional and educational resources, including a portal blog where you can be kept up to date on any new data like the acidification maps or new tool enhancements that are important to help you use the portal. We have an ocean stories section, which is kind of our homebrew story map meets digital magazine platform. We have a calendar that shows upcoming webinars like this one and meetings. And we have past webinars like this one, which will be posted online probably within a day or two of this conclusion. The portal team currently is Monmouth University, where I sit, Rutgers University, Duke, our developer EcoTrust out of Portland, Oregon, and we work under the guidance of the Mid-Atlantic Regional Council on the Ocean, or MARCO. And if you're not familiar with MARCO, it is a consortium that was formed just in 2009 by the 5 states of the Mid-Atlantic, which we consider as being New York down through Virginia, to work together on ocean issues. It's currently chaired by the state of Maryland. And I think this slide is a pretty good segue to introduce my colleague at MARCO, Janet Reamer, who can also talk to you about MACAN and give you some context on that.
Thank you, Carl. For those of you who are not familiar with MACAN, I'm just going to give a little bit of background and then kind of how we got interested in this project, and then turn it over to Carly. So my name is Janet Reamer. I'm the Science Program Manager for MARCO. And one of the programs that I help manage is the Mid-Atlantic Coastal Acidification Network, along with Kirsten Wakefield from Maracus. MACAN is essentially a virtual network of scientists, federal representatives, tribal representatives and state agency representatives. We're also resource managers, folks from NGOs and other industry partners. And we kind of are charged by NOAA's Ocean Acidification Program to kind of come together around the water quality issue of acidification. Acidification can occur in our open ocean, but it also occurs in our coastal ocean and inland bays, and it can be highly site specific. So having layers like this on the portal can be very useful for resource managers and those of us that are trying to determine where additional monitoring needs to happen so that we can kind of understand the drivers of acidification, but also how to deal with solutions. So again, we're part of this kind of national network of 6 different coastal acidification networks. And on this map, you can see where all of the acidification networks are located. And we kind of overlap regions because we acknowledge that water doesn't stay put, it moves. And so we work very closely with the other coastal acidification networks around the country. Some of our goals are to guide regional observations, research and modeling. We want to understand local drivers of acidification. So by local, we mean, kind of what's going on in state and smaller scale waterways. So we're not as concerned with the open ocean as we may once have been, but really try to focus on what's going on right now in the coastal waters. We contribute to studies that will help direct direct how we deal with the consequences that could potentially occur with marine resources and local human communities as well. And we try to coordinate best practices for monitoring and data collection on the regional scale. And we're also very involved in educating stakeholders on coastal acidification impacts and solutions. Our stakeholders generally tend to be any ocean user in the coastal zone and up in watersheds. Carl, if you could go to the next slide, please. Our outreach includes webinars, and we have our next webinar, which is scheduled for April 24th. It's going to be given by Ray Najjar of Penn State University, and I'm very happy to say that we're kind of reaching out of our traditional region into a state that isn't always represented as a coastal state. However, the Chesapeake watershed is quite extensive up into Pennsylvania, so we're very happy to have Ray Najjar. If you would like more information about this webinar or wish to attend it, you can register on the MACAN website, which is midacan.org. So we hope to see you for not only this webinar, but additional MACAN webinars. So from there, I'm going to throw it over to Carly, who has been working on this project for the last, year and a half, Carly? Something.
Yeah, I think so. Great. Well, thank you so much, Janet. I'm going to share my screen and we can get started. Okay, great. So I think that now everybody can see the PowerPoint presentation. So we can get started on that. And then I just have to get all the little pieces out of the way. Okay, perfect. Great. So thank you so much, Janet and Carl, for putting this together and for introducing both the MARCO Ocean Data Portal as well as MACAN and its role in the region's efforts towards ocean acidification monitoring and solutions. And thanks to all of you for coming to hear a little bit more about this data layer, the Mid-Atlantic Acidification Monitoring Inventory. This is a data set that is currently publicly viewable and downloadable on the MARCO Ocean Data Portal. And I'll be giving a little bit more background on how this data set came together, what's in it, and how you may be able to use it. I'll also be putting in some polls along the way so that we can get your feedback on how you can best be utilizing it and how we can make that happen for you. Ultimately, this data set was made so that people can use it to answer questions about where and how ocean acidification is being monitored in the mid-Atlantic. So hopefully today I can make you a little more familiar with the possibilities of how you can use the data set. But I'm also hoping we can have a little bit of dialogue and Q&A at the end about how we can make this data product work well for you and your needs. I'm going to start with a little bit of background on ocean acidification so that everyone in the room is on the same page, up to speed, and then how we monitor ocean acidification. So since the Industrial Revolution, we've seen substantial increases in atmospheric CO2 due to human-caused emissions. And as CO2 in the atmosphere has increased, the ocean has absorbed a lot of that CO2, around 30% of human-caused CO2 emissions. And as you can see on this plot, we have increases in CO2 in the atmosphere mirrored by increases in PCO2 in the ocean. So by taking up some carbon, the ocean is regulating some of those felt effects of climate change. However, this in turn has led to ocean acidification, which is a decrease in seawater pH that we can see in this light blue line right here. And we've seen a reduction of around 0.1 units of surface ocean pH relative to pre-industrial levels, which is equivalent to around a 30% increase in acidity. And we expect surface ocean pH to continue to decrease, with pH reductions averaging around 0.3 units relative to pre-industrial levels under RPC 8.5. In the mid-Atlantic, the northernmost states of the region are projected to cross critical biological thresholds for bivalve larvae growth and development between 2071 and 2099. So we have some of these more critical effects on the horizon. So we know that the ocean is undergoing these long-term changes due to human-caused CO2 emissions, but what else is driving those carbonate system patterns? Localized environmental conditions can lead to variability in the carbonate system at the regional and coastal level. Things like low pH freshwater inputs and local ecosystem metabolism can all alter the carbonate system coastally and also add a lot of variability when compared to the open ocean. Human impacts especially can alter carbon systems locally. Nutrient pollution from wastewater and agricultural fertilizers can be transported to the coastal ocean via rivers and lead to eutrophication and subsequently more acidic water. In the mid-Atlantic, for example, the Chesapeake Bay is a highly eutrophic estuary. So we know that there are these long-term changes happening from climate change, and there can be a lot of variability due to coastal processes. So how do we figure out the local level of severity of ocean acidification in the mid-Atlantic, in all of these different state waters, and also in the open ocean? And the most straightforward answer to this is through acidification monitoring. And we can do that by measuring seawater carbonate system parameters. And a lot of this monitoring not only helps us understand in real time what the carbonate system and what acidification looks like, but it can also get folded into models that can help us predict at a larger scale what the level of acidification is, and also predict future conditions. There are 4 parameters that are used to characterize the seawater carbonate system, and those are PCO2, dissolved inorganic carbon, or DIC, total alkalinity, TA, and pH. And by measuring any 2 of those carbonate system parameters with temperature and salinity, the other 2 can be estimated, granting us a full understanding of that carbonate system. And there are many, many ways to go about measuring these different carbonate system parameters. There are discrete methods, which can be done using a handheld sensor or by collecting a bottle sample that you bring back to a lab. There are also continuous methods where sensors will collect samples every few minutes, assessing things like pH and PCO2. Research cruises can do a combination of discrete and continuous methods and help us get out into the farther reaches of the ocean. And finally, glider deployments can get those depth varied, high frequency measurements, also at a high spatial resolution. So as you can see from all of these pictures, there's many, many different ways that people in the mid-Atlantic are monitoring acidification. And that brings us to the data set itself. So the MACAN acidification monitoring inventory, the goal of this project was to build an inventory of acidification monitoring efforts in the Mid-Atlantic region, including any sites where PCO2, pH, DIC, or TA has been measured. So we want to know where carbonate system sampling is being conducted, when that sampling was done, including at what frequency, is it happening continuously, or are they more discrete samples every month or so? We also want to know in terms of the temporal, like when was the sampling done? We want to know what season it was done in, how long in duration was a site sampled at, and if it's still active or if it's an inactive site. And then finally, the last bullet point we have here is how was that carbonate system sampling conducted? What methods were in use? Was there a particular sensor that was being used? What were the quality control methods? Were there any additional parameters being measured alongside? Maybe they were measuring biological parameters as well. So we try to answer all of these questions in this data set. The where, the when, and then also the how. The study area is generally focusing on the Mid-Atlantic. So sampling occurring within Mid-Atlantic state waters, which is, as we talked about a little bit before, that includes Virginia, Maryland, Delaware, New Jersey, and New York. But the study area also extends out into the Mid-Atlantic Bight. The last time an inventory was put together for the Mid-Atlantic region was in 2017. So I was just focusing on updating that existing inventory and including that 2017 to 2023 time period to fill out any new carbonate system sampling that's been done in the past few years. Altogether, the inventory includes sites active anywhere between 1984 and 2023. So it's a large amalgamation of many, many different sampling sites, some of which have been recently active and some of which have been, it's been a while since they've been active, but it kind of helps us understand a sense of any historical monitoring that was going on in a location. In order to collect this new round of data, MACAN sent out a survey for about a year to people conducting acidification monitoring around the region to begin to fill out that inventory with new information. We got around 35 responses on this survey, and the rest of the data was filled in from publicly available sources like VCOS and NCEI. I'll also mention now that this is a living data set, so if you have any corrections to make, or maybe you are starting to sample at a new site, please reach out to us, and these are things that we can incorporate into the next update that happens on this data set. Yes. And this is the results that we published on the MARCO Ocean Data Portal and that you can access there. We wanted to take this opportunity to expand our understanding of what's going on at each monitoring site. So if you go to view or download this data set on the portal, you can click any site and get a lot more information about the sampling that's going on there. There's information about biological co-monitoring, what instrumentation was in use, quality control methods, depth of measurements, and much, much more, as you can see on this as we're scrolling through that available information tab. The intention for this data set is to be a resource for groups engaged in ocean acidification monitoring so that we can identify data gaps and also collaborate at the regional level to fill in those gaps in our understanding. In order to access this data, you can, of course, go to the MARCO Ocean Data Portal. Once you're there, these data are viewable as the first thing that pops up under the Water Quality tab right here. There we go. From there are a few options for how you can view this data. You can view all of the acidification monitoring sites at once. You can also view sites that were active as of summer 2023. You can view a layer by the number of parameters that are being measured, 1 through 4. So that's that PCO2, pH, DIC, and total alkalinity. And you can also click through to see where each specific carbonate system parameter is being measured. So if you're just interested in pH, you can click on that pH sites layer and just view sites where pH is being measured. And likewise for those other parameters that we discussed. The second way that you can access this data set is by downloading it. And you may be interested in doing this if you have a very specific question about the data set that requires deeper filtering or sorting or your own GIS analysis. So you can download it as a geodatabase directly from the MARCO Ocean Data Portal by clicking on that little eye, and then you can see that there's that download as reformatted data set available right there. Or if you'd prefer to manipulate the data as a CSV, the DOI that's presented right there will take you to a downloadable CSV of the data. And I mentioned before that there is a lot more data about each site than what first meets the eye. So the MARCO Ocean Data Portal has some of the most important ways to look up at the data already as those clickable layers. So you can click through and toggle through those different viewing options. However, for a lot of sites, we were able to also fill out data about many other things. For instance, the measurement depth, whether a data set is publicly available or not. And if it is, we do link to that source data right there. We also have information about what the data quality or QA/QC methods are. And then we have some information about the sampling timeframes. So sampling frequency, seasons active, sampling duration, for example. These extra details can all be viewed if you click on any one data point in the portal, and then you'll get all of those extra pieces of information that we were able to gather about a particular site. Or if you're downloading the data set, you can also manipulate them based on these other feature classes as well. But currently, these feature classes are not things that you can toggle on the map to view on the MARCO Ocean Data Portal. This is what you can do that with. And I'm sort of gearing up to get some feedback on some potential new layers. So I just showed you a lot of parameters that could be potential new feature classes on the MARCO Ocean Data Portal. But we're really interested in including things that are useful to the people who are using the map. So if you want to participate in this poll, you can scan the QR code and rank the features that you're most interested in making viewable as a layer on that MARCO Ocean Data Portal. So currently we've got measurement depth, data quality, looking at climate, weather, or undefined quality, publicly available data, seasons active, number of parameters measured, which is one of those things that's already on there, sampling frequency and duration. So this poll will keep going after I move on from this slide. So if you are interested in participating in this survey, feel free to grab a snapshot of that poll QR code now, and you can fill this out anytime throughout the meeting. Okay, so there are many possible ways to use this data set, but I'm going to highlight 3 different ones today and provide a few examples. First, this can be used to aid in site selection and planning for future research to see how a new project fits into other current and past sampling efforts. For the Mid-Atlantic, it kind of serves as another engine to find that publicly available data where you're able to pull from many different sources at once, instead of maybe only looking at the tracks of one specific cruise, for example. Second, this data set can be used to better understand spatial and temporal gaps in acidification monitoring. For example, for this, if you're interested in a particular aspect of how acidification monitoring lines up with a habitat of interest or another parameter, there are lots of options on the MARCO Ocean Data Portal to explore, and you can actually toggle many maps on at once and view several maps at a time, so that you can kind of layer these monitoring sites on top of other habitats of interest, or perhaps ocean GDP. Many options here if you're interested in seeing where monitoring is happening with respect to another spatial map. And then finally, we also hope that this fuels collaboration at the regional level. If you or your institution is conducting carbonate system monitoring or sampling, I highly encourage you to look at the map and see what your neighbors are measuring. There are many sites, for example, that are measuring one carbonate system parameter, which you can see here on this map. Those lighter blue triangles are just one parameter. But there are far few measuring two, especially in the coastal zone. We have a lot of sites with just one parameter being measured. And this, if we have two, we're able, plus temperature and salinity, we're able to estimate the other two. So getting to that second parameter does greatly increase our knowledge of any particular site. So what we hope is that if you're looking at this map and you notice that maybe you could collaborate with your neighbor to get to that two parameters being measured, that would be an excellent outcome for future research. There's also the potential for many partnerships in co-monitoring biological processes with chemical processes and more. So as you're looking at this map, another way that you can think about it is how can you foster collaboration at the regional level or state level using the resources presented here. One of the applications that I just discussed is site selection. And so I'm going to give a particular example of how I've been able to use this for site selection. One way you can think about using this map is to set up a new project where you're planning either in situ carbonate system sampling, looking at this map and understanding what gaps you could fill, or if there's any local historical data that you could build off of. That's one way to use it. Another way would be to use it would be to find publicly available carbonate system data to answer a new question. For this, I'm actually going to use an example from a meeting I had yesterday. One of the current MACAN fellows, Nicole, I don't know if she's in the meeting or not, but this is going to be about her project. So Nicole's in the process of picking out some sampling sites with publicly available data that she can pair with satellite data that she's using for her project. So if you've downloaded these data and you're looking at them in either a CSV or on ArcGIS, you can kind of take it a step further and take all of these criteria that you may have for a specific project and then filter through the data set based on those criteria. So for example, if we start out with all of the sites in the Mid-Atlantic, and then we filter it so that only publicly available sites are visible, and then filter again so that we're only seeing sites measuring 2 or more carbonate system parameters, this might be a good place to start if you're trying to find sites that are going to serve your project well. I've also been doing some analysis of this data set to dig into where monitoring is occurring with respect to vulnerable habitats and locations that may exacerbate acidification. All that will be published as a sort of companion document to this data set. So if you're interested, you can stay tuned to MACAN updates in the near future. I'm going to highlight one of those analyses to show you one other example of how you can dig into this data a little more. One habitat that is vulnerable to acidification is coral reefs, which we actually have in the mid-Atlantic. We have deep sea corals offshore. And this map is also from the MARCO Ocean Data Portal, and it shows modeled coral habitat in the mid-Atlantic, with the different colors representing the different coral densities. When we intersect the coral area with the monitoring inventory, we get 600 sites within the coral area, but we can go a little deeper on this, pun intended in this case. So these are deep sea corals. They're living at depth in the ocean. So let's check out the depth at which these sites were sampled. Here, the reddish orange dots are surface samples, and the white dots are locations where samples were collected in profile. So that's at many depths. So now we have 99 out of those original 600 that are capturing the conditions that corals are actually experiencing at depth. So that's just kind of walking through another way that you can sort of piece together some of these different features that are available within the data set, one of those being measurement depth. And there are so many other different relevant data layers on the MARCO Ocean Data Portal that the OA monitoring map can be integrated with. These are just a few examples that I grabbed screenshots of, but the possibilities are really endless depending on what your interests are. And then I'm actually going to, at this point, going to stop sharing for a moment and then come back with just the MARCO Ocean Data Portal open itself so that we can kind of walk through how to use it on the portal. So. Okay, great. So now that we're on the portal, we can kind of check out how you can view these data and also how you can integrate with them with some other data sets just right here on the Ocean Data Portal without having to download anything. So first, if we're starting with a blank map like this, we go to data, and then we can scroll all the way down here in the water quality tab. If you click it, we've got our acidification monitoring locations right here. And if you click on the down arrow, you can see all of the different layers that are viewable within this data set. So we'll start out with all of the acidification monitoring sites to start. And then I actually wanted to bring up an example from, so I just showed you the soft coral habitat, and that was a GIS analysis that I had done myself after I had the data downloaded. But you can do a very similar thing just by putting multiple layers on the portal at once. So here we have the habitat for soft corals. We can put that on as well. And you can kind of see it in the background here. But if we zoom in, if we're looking for sites where, if we're looking for any monitoring sites that pair with this soft coral modeled habitat, we can kind of see where they overlap here and then click on any particular site and get a little more information about how that monitoring is being done. So in this case, we see that this was done in 1996, was collected on a cruise. They were taking continuous samples, and they were measuring pH and PCO2. So we have two carbonate system parameters being measured there. We also have the additional parameters of temperature and salinity. And you can access some more information about this on this website here. You'll notice that some of these are filled out with null. Some of the older data that we have, it was a little bit more difficult to get some of that deeper information about what's going on. But a lot of the newer data that was added, especially from the last 5 to 10 years, there's a lot more metadata about the sampling that's going on. So you may see all of these filled out, or you may see some of them with a little bit less information. So we can turn off that soft coral habitat and just look a little bit more at these sites that we have in order to figure out what the colors are. So here you can click on this legend tab, and any sites that you have active or any layers that you have active it'll show you what the colors or symbols mean. So in this case, we have them colored by the type of data collection that's going on. So we have continuous bottle or CTV data, continuous and discrete data paired in one location, several types of cruise data, and then discrete and glider data. So these red lines are our glider tracks. And then I'll just briefly click through some of these other options. So here are sites that are active as of summer 2023. For this in particular, if you know that your site is active and it's not listed as such right now, let us know and we can add it in. We also have sites by number of parameters. So we already saw a little bit of a screen grab of this, but here we can see that a lot of our sampling that's going on along the coastline, we're only measuring one parameter. And then once you get out into the open ocean, we have more of that darker purple and pink and yellow that shows what in particular there's more than 2 or more parameters being measured here. And then we can go through, so these are our pH sites. These are our PCO2 sites. Total alkalinity, and then DIC. So I think now that we've walked through a little bit more of what's available on the portal and some different ways that you can use it, I'm going to stop sharing my screen for now. And from here, I think I'd be happy to take any questions, any comments or things that you would like to see in terms of functionality from this data set. Would love to hear anyone's thoughts on that. So thank you.
Thank you, Carly. That was awesome. I really appreciated that, and especially just hearing about the ways that you're using this data and some of the analysis that you're doing. Really cool, and I look forward to seeing that when it is published or shared around. We do have one question in the chat, which is from Will Eisenberg, and he was wondering about the difference between the monitoring sites that are just named cruise and the other two cruise types, which I think are discrete. And I'll get that wrong, but I
And
hand it over to you.
Yes, that's a great question. So this was because cruises sort of can conduct monitoring in a number of ways. Sometimes they have a sensor where they're sort of it's attached to the cruise ship itself, and so as they're moving, they're collecting continuous data. So you kind of have a track line of data where you may have every 10 seconds or even 2.5 seconds, you'll have a point along that track line of what is being measured there. So in that case, and then another way that cruises can measure acidification is just through discrete samples. So earlier in the presentation, I showed sort of, there was a very large, what we call it, rosette cast. So like a large, like sort of instrument in order to sample like at different depths, so that can be deployed at any one location to get like one sample at a time from a specific location. So because there are sort of multiple ways that cruises are collecting data that kind of influence how we're going to see and use that data, I wanted to break up how that collection was happening. So some cruises are doing both of those things. They're collecting discretely and continuously as the cruise track. So underway samples is how we would represent that continuous cruise track sampling. Some are just doing one or the other. And then some cruises didn't have, especially some of those, the older data that we had, just didn't have as much information about how the sampling was happening. So at this point, that's, we were just labeling those as cruise alone, just to not make any presumptions about how those data were collected. But one of the goals that I have is to slowly do a little bit more digging and build that out so that we know exactly for each cruise if sampling was happening discretely or if it was happening continuously. So that was perhaps a longer answer than we bargained for, but thank you for your question.
Who else has a question? I thought I saw a hand up at one point. While people are thinking about it, I'll throw one out, which was, so the original, I think originally we had one acidification monitoring map, which was the all. This is going back to like 2017 or 18 when MACAN was really first getting started in its work. Then it expanded to show the various parameters being monitored, and you know, we had the half dozen or so maps that kind of show today. And I think maybe 2 or 3 years ago, there was a lot of data added and expanded a lot of the points on screen. I think the biggest thing I noticed was the addition of the glider data, which wasn't there at all before. So what with this latest iteration would you say has changed the most from what used to be there a couple of months ago?
I would say the glider data is a really big addition. I know a few years ago, sort of the first couple rounds of glider data were incorporated, but even since then, I think I added 13 more glider tracks to the data set, which just encompass a huge area of really high quality and high frequency measurements. So I think that's going to be really interesting and really helps fill out some of the gaps that we had in that area before, specifically around that New Jersey cold pool area. But I think beyond that, one of the things that I worked on adding was a lot of the sites that may be measuring pH especially, or some of the other parameters as well, more in a water quality capacity and maybe they're not thinking about it in terms of acidification monitoring specifically. So these are sites like a lot of along like the Virginia coast, like the V coast sites. There are hundreds of sites that have deployed sensors for multiple years in a row that are measuring pH and some other parameters. And while a lot of these only have one parameter being measured, it does kind of increase our spatial understanding, especially in a place like the Chesapeake Bay, where we have a lot of heightened acidification effects happening. So I would say kind of increasing, sort of including some of those other sites to expand our understanding of where people are measuring pH, and see if we can sort of leverage that, even if maybe their intention wasn't initially to measure ocean acidification, but something else. So I think that would be sort of the thing that I was very excited about including.
Who else has a question? I'll throw out one more if I'm hearing none. So this is to you, maybe to Janet. Janet showed that map of all of the different networks, the acidification networks that are around the country earlier. Are any of them doing anything comparable to this in terms of developing this kind of comprehensive map data showing where monitoring is taking place?
The short answer is yes, but not many. I think Janet might be able to jump in and give a little bit more information, but I think that the biggest example of where this is happening is in on the West Coast. I think it's in the Pacific Northwest. They have a pretty robust map of monitoring sites, and also I think in the California Current. But this is, I believe, the only one on the East Coast. Janet, do you want to jump in and confirm or deny?
I believe that MACAN is trying to start up an initiative like this. I'll just kind of throw it out there that not all cans are created equal. There is not equal funding to all of the cans, just because of the way that we're structured and the associations that the different cans have. NOAA has a database, the National Center for Environmental Information, that does have most of this data and information in it, but it's not considered kind of a decision-making tool the way that the portal is considered. You can go on to NCEI and obtain all of this data, but it's not going to be mapped for you the way that the portal maps it. So that's kind of one of the advantages of MACAN undertaking this initiative, is that we can provide it in a decision-making tool, and then we link to the actual data that you can get from NCEI. So all of the data that Carly was talking about is publicly, well, not all of it, but the majority of it is publicly available through NCEI that we link to, but the way that it's presented on the portal is definitely different than NCEI. And so, like I said, not all the cans have had the funding and capacity to do this yet, but it is certainly on the radar of most of them.
I see a hand up from Will Eisenberg.
Hey, yeah. First of all, thank you, Carly. This is great. One thing I just had a question about, just looking offshore Virginia, seems like the majority of what has happened out there is this one, it seems like big effort from the Department of Energy / JGOFS. The link in there doesn't work, but I was wondering if probably just an old link being so old of data, but I was wondering if you knew anything about the history of what that was, why it was something that kind of traversed the area, some areas more focused than others, if you have any kind of insight on that.
I don't have any insight on that particular sampling, but Janet just unmuted. Do you have some more information?
Yeah, so there were a lot of so the JGOFS is the one that you're talking about, I think, and a lot of the data that is like early collection. So by early, I mean, anything from the early to mid 1990s through about 2007, a lot of that data wasn't even collected with acidification in mind. So in those instances, it's very likely that it's pH or PCO2 that was collected in likely not what we would consider climate quality today, but more the weather quality, which as Carly touched on a little bit. It just has to do with the precision of the instrument that's being used. Once we kind of realized in around 2007 to 2010 that acidification was in fact a global phenomenon, it's when we started developing best practices and like acidification specific sensors that have very higher quality, precision, and accuracy than earlier equipment. But the great thing about that early data is that we can incorporate it into long-term data sets to be able to look at like decadal change over time. And I don't remember exactly what the mission of the JGOFS cruises were, but I believe it was like basic ocean chemistry, nutrient chemistry, hypoxia. Those were kind of the early ocean chemistry cruises. I think there's also off of Virginia, there's a transect that extends out from the mouth of the Chesapeake Bay that has been resampled since the early 2000s, approximately every like 3 to 5 years. Those original cruises were called the GOMEC cruises, and then you have the ECOA cruises that started in 2015. So it was 2015, 2018, and then I think 2022. So we tend to refer to those early JGOFs as the historic cruises, but you know, it's a relative term. And all of that information is still available online. And Will, I can help you find it if you're really jonesing to get a hold of the original data.
I appreciate it. Yeah, I'm sure I'll be reaching out with more questions, but thank you so much. That was very helpful.
You're welcome. There's your history of acidification.
I appreciate it.
I also just wanted to jump in. Kirsten reminded me of this just now. So another product that's going to be coming out of this whole project is I've done a lot of analysis at the Mid-Atlantic level, but also at the state level. So for all of those states that are included in the Mid-Atlantic, looking at how many monitoring sites are in each state, how many are high quality, how many have happened in the last 5 to 10 years. So, and then also looking at like some of those important habitats specific to each state, because every state is a little bit different in terms of what their priorities may be. So I'll share my screen one more time very quickly. This is just a brief snapshot of what one of those monitoring fact sheets might look like. We're still in the process of kind of switching out, figuring out what the most relevant information is for everyone. But these will be produced for every state to kind of dig a little deeper for each state on what monitoring is happening within state waters. So if you're interested in that specifically, or if you have feedback or ideas about things that you would want included on your state's monitoring fact sheet, specific things you're interested in, drop us a message, let us know, and we can definitely make sure that's included.
Very cool. So we are approaching 1 o'clock now. Carly, is there anything that you wanted to say to wrap up?
Just thank you everyone for coming, and I really, I hope that you're able to kind of play around with this data set on the Marco Ocean Data Portal and kind of use it for whatever your needs may be. And feel free to reach out if you have any further questions about it.
Excellent. And thank you for doing this. Thank you to everybody who joined us today. And we'll be adding this to the portal site and to the MACAN sites probably within the next 24 hours or so, a recording of this. And yeah, Carly, congratulations on completing this and look forward to seeing what's coming next.
Awesome. Thank you.
Have a great day, everybody.